All right, awesome. Well, good morning, everyone. My name is Anthony Bornero. I'm with SP Permian Basin, with the SP Permian Basin Data Analytics Study Group. We're gonna give folks a few more minutes to trickle in and probably start at 11:35. I know a bunch of people are probably jumping off meetings at 11:30. Whenever joining us, so we'll start shortly. So stay tuned, and I'll kick us off in about 4 minutes. All right, let's get the show on the road. Folks will start coming in as don't wait any longer. Yeah, so welcome everyone. Thanks for joining us for today's webinar with Corva. My name is Anthony Bornero, and I'm with the SP Permian Basin Data Analytics Study Group. So we have Michael from Corva here to talk about some of the data analysis techniques they use in some of their platforms and how it helps them, like use cases. One of them is like optimized chemical set points. So we'll learn some more about that. Just a little housekeeping before we get started. We'll be doing the Q&A at the end of the presentation. So if you have a question for the presentation, please feel free to submit it in that little GoToWebinar panel on your screen, or raise your hand towards the end, and we can unmute you and you can ask your question to Michael. And then again, if we don't have any time, if we run over, Michael and the folks at Corva can respond to your questions that you have that we did not get to. So do not worry. and you will get a recording of this and down the road once it's uploaded, and then also we'll put on our social media. I think Corva will also put on their social media. Without further ado, let me hand it off to Michael to get talking about Corva.
Thanks, Anthony. So hello, everyone. My name is Michael Louder. I'm a drilling completions engineer here at Corva, and today, really what we're going to go through is showing everybody kind of a good general overview of the platform, how we kind of go through our process, how we acquire all this data, and then really the platform itself and how we make everything actionable. So quick agenda, just to kind of hit the high points of what we'll be discussing today. So to set the stage, kind of just overall challenges and stuff that we have seen from our side in terms of as an industry, and really from there, our approach of how we can fill in those gaps, help customers, make operational decisions that are more effective, more efficient, cost effective. Top of that, our general track record, and then really the meat of the presentation, demonstration of the platform itself with case studies mixed in, then finally question and answer session. So really, and like I said, to start the stage, common data analytics challenges. So something that we've seen, and even from my previous experience working for an operator actually out in the Permian, is one, how do we get all this data, especially on the completion side? Now, Corva is both a drilling and completions platform, integrated platform, but especially since we're going to focus on the completion side today, how do we deal with all of this? So first is the data volume. So to those that are familiar with, your typical unconventional completions operations, you have all your frac data, wireline data, pump down data, all this information that's coming in. We're talking, let's say on average, a 3-well pad that has 50 stages each, so 150 different stages, different files of data. That's just your raw data coming in, how you're treating the well, how effective you are at putting the job away. On top of that, what do we, how can we leverage some of the drilling information for all these wells? How can we leverage, and especially on the completion side, not just operationally, just being effective at getting the job pumped away, having a safe operation, but two, overall production impact. How are we, planning to where we have the best possible frac, most production, at the end of the day, helping our company out. A couple other pieces as well. So, and we've really seen this on the completion side. So as an industry, really completions, and especially kind of going further down the line of, well intervention, clean out, so on and so forth after the drilling phase, is the data format. The format of how the data actually is, it's, for lack of a better term, it's the Wild West. There's not much consistency from vendor to vendor, from, even on the customers. Everybody has kind of their own flavor of how they acquire the data, how they send it. So that becomes, it makes a pretty big problem of how do we get it all in one spot and organize it? Because that's a huge undertaking in itself to make sure this data is actionable. Other two pieces, the data quality. Of course, kind of the old adage, garbage in, garbage out. If we aren't getting, with all this data, and it's kind of the mantra of the times is, data is the new currency these days, where it is very, very important to have this data, to leverage it, to make decisions. And even kind of as I touched on at the bottom of the screen, and, quote I sometimes say, if you can't measure, you can't improve. If we can't use the data that we have, and if it's not high quality and it's applicable to our operations, it's unusable, even if we have the best techniques, analysis methods, so on and so forth. Finally, another challenge is data visualization. So much of a way, again, there's so many facets, especially on the completion side of, how are we going to visualize this data? How are we going to look at it? How are we going to, again, make it actionable, make decisions off of that? So from as you can see to the left, that's more of the challenges that we have. And then from what you can see to the right are the key enablers. Those are kind of the focal points of what's required to make all 4 of those kind of challenges successful. So, within organizations, we have to have a digital champion. We have to have somebody that's really spearheading the charge to make sure, hey, can we wrangle all this data and have it correctly? Can we develop methods and techniques to, handle the volume, to QA/QC this data? That again, that goes into, organizational adoption. Do we have the processes in place to basically make all this work effectively and efficiently? And then of course, and this is where we come in, the digital technology. So that's where we really reside and sit to help customers with that facet there. So leading to the challenges, this is really where we feel we fill kind of the gaps in terms of an integrated platform, especially on the completion side. So as you can see, here's a little pie chart right here, and I'm not going to cover all of the pieces on the outside, but mainly the pieces on the inside. So, you know, as an industry, and it kind of mirrors what we have from the first chart that we saw, but, you know, to be a fully comprehensive platform, you know, one, getting all this data, having it all together. Do we have a way to actually, you know, have real-time visualization from the field to see what's going on, to give us, you know, a peek behind the curtain to know, hey, are things going as efficiently as they can? You know, how do we do that? Big piece of what we do at Corva here is our data quality. So an aspect, we have a real-time operations center comprised of actual individuals with field experience, both the drilling and completion side. So they are, you know, automatic. So we have methods of, you know, automated QA/QC through coding, through parse bots that make sure this information that's coming from the field that is correct, that then when it goes into our applications that you can visualize and show, it's usable. On top of more manual QA/QC methods, you have people, again, industry experience checking, making sure this information that's coming in, it's correct. They will correct and then basically go back and make sure with the folks, with the customer, that all of it's in the same spot and it's the way it should be. Integrated analytics. So again, you get the real-time information, you know, full kind of view of frac, wireline, drill outs, everything to be able to view, show, but then integrate analytics from it. So from that standpoint, you know, automatically calculation of all your key KPIs. If you're wanting to pull in offset pressure monitoring for, you know, frac hit mitigation, loading historical wells so that you can compare, you know, previous well performance to current to see if you're improving, if there are places that we need to really focus on to get better. And I'll show that in some of our applications in the demo. And finally is an enterprise aspect of the solution. So in terms of being sticky, you know, since all this information is coming from the field, it's going to Corva, we're QA/QCing it. You have one central place where all this data is being organized to where customers, you know, in terms of, we're trying to get a lot of customers, they want to get people footprint off location. So, you know, automating reports such as, you know, our direct connection to WellView to send stimulation information, to automatically populate these reports, you know, sending information to analytics tools like SPOTFIRE, Power BI, things of that nature. A lot of teams or customers use Microsoft Teams or Slack. So integration with those to push our information to give teams updates. So again, consultants aren't having to, you know, type up reports or all of that. They can focus on the job at hand, being more efficient. And again, facilitates communication across the team. But really, the whole aspect of this is, you know, a comprehensive platform that covers not just real time, not just analytics, but, you know, it integrates with other solutions. We QA/QC the data. We're all comprehensive and inclusive. So here, quick snapshot of where we're at today, some of our experience and what we've worked with. So, and really, and it'll show kind of on the next slide where we've gone. So in terms of Corva itself, you know, we started as a drilling service essentially on the platform. Completions is actually relatively newer, but we've grown at a pretty quick, staggering pace really in about a year and a half once time. So, you know, over 1,000 wells have been monitored using Corva, completed with it. 10 million lateral feet. You know, we're processing about 500 gigabytes of data, QA/QCing that a day. You know, the Permian Basin actually is our biggest area and our largest customer base, but we have a breadth of experience outside of those. So 10 different operational basins in, you know, North America, so Canada, the US, lower 48, as well as Argentina. In terms of people we can work with, 25 plus pressure pumpers, wireline companies, drill out companies, and counting. So in terms of, you know, what we'd like to call vendor agnostic, so where, as I mentioned, how a lot of this data is coming in, everybody has their own flavor of it and way of transmitting it. We've helped that process and improved it and kind of made it to where we can convert that information. And then as well, just market share. We're about 20% of the frac fleets really in the unconventional space. As I touched on, really wanted to show this. This is just kind of an outline of, you know, where we've come to date. So, you know, really the drilling aspect, and that was something that was really started back in 2014, fully went commercial 2018. But what I really want to highlight, so we have about 65 apps on the drilling side. Currently, we have over 35 apps on the completion side. But in terms of kind of our learning curve and our ability to develop new applications, to come up with solutions quickly, we've really sped up that process. So like I said, drilling's been around probably about twice as long as completions. And as you can see, we're almost, you know, 2/3 of the way. the number of apps and counting. So the beauty too is it's an integrated platform solution for your operation. So as most know on the completion side, leveraging that drilling data can be critical to not only operational performance and improvement, but your actual production data, your reserves, all of that. So now I'm going to go actually into the demo and really cover what we have in the platform with some case studies. So to start right here, and really what I want to first cover is just the general, how the platform works. So this actually is Corva itself. Corva itself, it's an app-based platform. So as you can see right here, all these individual tiles are different applications in the platform, and they all serve a unique purpose, whether they're, a PRC plot or a treatment plot, actually streaming real-time data from the frac van so you can remotely monitor a job, or we have analytics type applications that are just going to calculate your transition time stage to stage, all your track chemical usage set points, as mentioned at the beginning by Anthony, and I'll show how that works as well. But all of these features, and these are all part of our 35 plus applications that show us and really, add value in a variety of ways. So all these tiles, individual applications in the platform, and you'll see as I go through, I just want to give a kind of introduction of what you're looking at before I show you. But as you can see here, up the top right here, default view. This is called the dashboard view. So the dashboard view in Corva, that is a user's own customized configuration of apps. So you can see right here, real-time frac and wireline. So I've actually made these in our demo account. That's what I'm in right now. But all these individual apps, so in this particular case, they're all apps that would be used in a real-time fashion for frac or for wireline. For the analytics piece, again, just apps, all of that. But the beauty of all of these is that they're totally customizable for the user. So for instance, if a certain user, all these tiles, different apps on a page, they wanted to add new apps to a particular dashboard, it's very configurable. You just click add app, it'll then take you to the app store. So you can see right here, this is actually where we have all of our apps from the drilling or completion side. So if I wanted to focus on particular completions apps, I could click on the segment right there. I can also search for it up top. So if there's certain information, let's say I do want to have a treatment plot, I can just type it out and it'll automatically find that information. I spelled it right there, but let's say activity detection. And then it'll be right there. So if I want to add an app to a dashboard, very quick and easy, you just click it right there. You just tie it to a frac fleet or whatever you have loaded into Corva, and then within seconds, you have it loaded onto your dashboard. So very quick, very easy to pull all this information, see it, visualize it. Now, a couple things with it. As I said, it was configurable. So if we want to move apps around on a dashboard, all I have to do is just drag and move it around. And as you can see, I can do that right there. If I want to resize or reshape apps, I have that feature and functionality right here as well. So again, very user-friendly, customizable. Again, I could always go back to the app store, add new apps, as many of the same different apps as I'd like. And again, it could be totally customized, especially if, we have customers that have multiple frac fleets and they want, multiple kind of pad metrics. So showing all their pumping KPIs all side by side. So again, it's a quick analysis and tool to visualize and see that information that it can help them in the future. So again, adding new apps, creating new dashboards, that's just this right here, all very seamless, very quick, very easy. Before really going into the individual apps and how we can use them, is just one, like some functionality pieces. So I want to look at the far right, all these dashboards, variety of features we could do with them. I could sort them, I could change their name, but ones I really want to highlight are the sharing and schedule reports feature. So sharing, what this allows me to do, and again, it's facilitating communication across teams. So let's say I want to, have maybe I have a power user and they put together a lot of various apps on particular dashboards. There's a quick way that they could actually share that information with the other users. All they have to do is click the name of the user that they have. They'll have it, save it, and they'll have access to that on their dashboard. Other features as well is a scheduled reports feature. So again, a great example is a type of morning report. A lot of customers use it for, they'll put all of their kind of key KPIs, and I'll go through these apps in a moment and how they're utilized, but their stages per day metrics, so on and so forth. All of that information, what they could do is automatically schedule a time that a report will be generated. So pick, let's say 6 o'clock in the morning before a morning operations call, then just type in a distribution list of those recipients. Once save is hit, it'll automatically generate a PDF screenshot of that dashboard and automatically send out to that team. So this has been a huge win for a lot of groups that are, maybe they don't have a big analytics department or a big means to generate all these KPIs to measure what they're doing to improve. This automatically does that for them. It updates it for them. And now they have a PDF to where management, engineers, folks in the field can all see it to then improve, see where they need to target, and go from there. So now, going to actually go through the individual applications and really hit home, the case studies, use cases, how the data is pulled from the field, so on and so forth. So fundamental on our real-time application. So I want to go through the real-time applications first because that really explains how the analytics works, how the rubber meets the road, so to speak, in terms of how are these things calculated, how because that's always a common question for trust for all the purposes. So treatment plot. So foundational app on the frac side, and what we're doing and how Corva works on the completion side is and as I mentioned, based on frac vendor to frac vendor, wireline logger to wireline logger, all of these kind of disparate, data sets, so to speak, they're all in a variety of means. There's not an industry standard really for the frac or wireline side in terms of how this data is transmitted and submitted, via cloud to cloud piece. So one thing Corva that we had to do to develop was a way to convert that so that we could be vendor agnostic, so to speak. So what we have done is it's develop a little box that actually plugs into the serial output port in the frac fan, Warrior in the wireline logger, that operating system, same with your pump down, and extracts the information from the sensors already on location. So we get that information, aggregate it, and essentially convert it to where it will populate our applications and our systems to where you can see the data populate before you and the apps that you see before you. So for instance, that's how we're able to get from the field to actually our cloud and our operations. So for instance, our treatment plot, we're able to get a 1-second view of the treatment data as it's actually live pumping and going on. So really, and how this has been critical and useful for customers is a lot of our customer base is actually using this to remotely treat their jobs. So they're actually pulling their consultants off location, which means, less safety risk. They're actually basically able to reduce that number. So then it cuts their costs and they're able to be in like a real-time remote center to call the jobs, remotely treat, going so on and so forth. So again, it reduces all of that headache, all that work, just having the box streaming that information in. Other things we can do with this application. So if you look at the bottom of the screen, there are a variety of blocks. So from those blocks, you could see how there's a yellow, orange, blue, so on and so forth. What we have at Corva is a set of activity detection algorithms that actually break out all of the operations that are going on a particular stage. And this is actually how we're able to perform our analytics, capture this information. So for instance, based on, rate start, proppant injection, calculating and pulling in from the real-time streams, breakdown, ISIP, we actually could tell when you're pressure testing, pumping pad, actually fracking, going to flush, or let's say we do have a shutdown in the middle of the stage, when that happens, and we can capture it and show that information. So that's critical to how it feeds into our analytics and all that portion of the platform. Beauty of this plot too, so whether I'm looking at actually wanting to post and put in individual, so virtually any channel from the van, we can map and display it here. You can also see it in a real-time view over here. But let's say offset well pressure. So this is another big usage, and I touched on that a minute ago, is we have the ability to, if a user has far field offset well pressures, they could actually beam that into the frac fan and we can map those channels. So again, if I want to show that information, this is just for demonstration purposes, I could overlay it, show it, and then as the job is actually live, you can see that information and view it from that standpoint. So very useful in terms of mitigating frac hits, all of that from that nature. And why I wanted to show this correlates and segues really well with our alerts feature. So for instance, let's say for offset well pressures. So in Corva, we do have a custom set of alerts that we have in the platform. So whether it's we want to track wireline run and hole speed, pump down rate, max safe pulls when we're, for tension when we're over pulling. If we want to have plug slip type of alerts, screen alerts, we have all these in stock. Now we could always change the thresholds. We can make custom versions of it. But let's say, for instance, offset pressure warning. What we can do is if we want to tie for that offset pressure, maybe we don't want it going over 1,000 PSI, we could turn that on, set it up. The alert could be sent to an individual either via text message, email, or what's called a push notification. So Corva has a mobile version of the platform that can be downloaded onto your phone, either Apple or Android. You have that piece. You could choose how you want it sent, and then you could choose which basically assets you want it tied to. So if you select that and show that, again, an alert could fire if you have a possible, indications of, hey, if wreck may be occurring, stop everything, basically stop course, shut in the well, see what's happening so you don't affect production from that standpoint. So just another use case of even how customers are using that currently from that standpoint for the offset pressure alert there. One final thing with the treatment plot that I wanted to showcase. So I touched on the analytics portion, touched on how virtually any channel can come in, including far field offset pressures, but it's the analysis portion of these stages itself. So let's say, for instance, I don't want to just have a real-time viewer, but I want to actually analyze my stages, especially for frac modeling, for the purposes of my development planning and maybe my pump design. So outside of just an active view, we can always look and see our previous stages. So if I ever want to pick individual stages, I could pick literally every stage or pick them out, and I could show them here. So in the case that I have, I've selected the last 5 stages on a particular well. The way I could select a particular well, I could either pick them right here, or I could do a pad mode. It'll show me every stage. But let's say from this point, I want to have all those stages shown. Maybe I want those stages overlaid instead of in series, so I could see my pressure rate response. So from that, just within clicks of a button, I could overlay these stages. I could show and correlate it off a breakdown or ISIP. So again, my pressure rate responses. So if I'm trying to utilize this, and again, this goes really well into maybe we have other frac modeling tools. All this data, it's QAQC that's shown. I can now see, and look stage to stage, well to well. Hey, maybe I need to change this type of part of my pump schedule, so on and so forth, to get my best SRV or all those pieces from that standpoint. So on top of that as well, maybe like I showed, I just want to have one well, overlay all the stages. Maybe I want a different well. Maybe I want to have the other offset well on the pad, overlay those stages as well to, again, see all those formats and look at any pressure rate responses. You could overlay any other offset stage, offset well on a pad that's loaded into Corva. So let's say we're fracking on the 3B, maybe the 4B is either another well on the pad or a far field well. What we can do, we can click it here. From there, I could actually select that well. It's in my queue as offsets. And maybe I want to pick those last 5 stages. Do 3 for demonstration purposes. Now from here, I could actually pick the color, the thickness of the line, all of those features. I click on that, and now I could actually see, and you can look through here, the dotted lines actually showing the 4B well versus the 3B well. So again, any comparison of stages, all of that, I have that ability to look and view and visualize it. So again, it enables all that decision making more quickly, and we have customers using this to help them for their modeling purposes. These 2 applications, proppants and chemicals additives, it's just really an extension of what we have up here for treatment plot. Same information, like I said, virtually any channel from the van. Good for analysis, great for just that remote treating and modeling, getting guys off location, better for safety purposes, better for reduction in overall overhead costs. Wireline traces, what this application is, very similar to what we have for the treatment plot. It's just on the wireline side. So we're plugged into the wireline logger, plugged into Warrior, and we can tell on a stage by stage basis, well by well, what's actually going on there. So we can display your line speed, current, tension, voltage, CCL, your pump down rates, pressure. So we can actually, every run, just as before, that remote treating, that remote monitoring of the wireline stages. Again, you could have an individual in a real-time center watching all of this, making sure all shots are fired, plugs are set on depth. Again, correlating, and I showed before that alerts feature could be used to show if plugs are off depth, to show all those pieces. So again, it reduces all that additional work and all those other pieces that are required typically from an individual on location. That's here as well. Another thing I wanted to correlate, just like how we have before, we have an activity detection piece for this side. So if I move this up just a hair, you could actually see where when you're running in a hole, when you're static, when we're pulling out a hole, our activity detection based on the real-time streams of information and those thresholds can actually tell when you're in and out of the hole. So again, automates that entire process, feeds into the analytics, but also for remote monitoring purposes, which are being currently used by customers. Our wireline parameters is just a further extension of what we have on the wireline traces. So it just shows in another view, this red ball would be right here, show your wireline location going down the wellbore path, up the wellbore path. Customers really use this, especially when they're getting into the heel and down the lateral, where they can correlate dogleg severity, correlate pump down rate, pressure. Again, tie those alerts to it to where if there's issues or problems, or they note, hey, we could have an area where we could see some problems. Hey, maybe we have an alert to fire that'll show, hey, you're getting too close to too high of a pump down rate. You may pump off guns, things of that nature. And that's how customers are currently using that to, again, mitigate any problems, showcase, hey, are we seeing a misfire? Are we seeing any trends to possibly go back to a company, for, basically improve performance purposes from there. So next set of applications on this dashboard are more of our analytics type applications. And these really cover how pulling in all this data, again, you saw how kind of on a real-time basis it works, how it can pull in, how we can see it, but now making some more actionable decisions out of it. So this is the prime case, it's called well comparison, and this shows how we can optimize chemical set points or really any consumable pumped. So what this application does, so again, all from the real-time streams of data, it's pulling in and recording your pressure and rate data on a stage-by-stage basis. So you can see up here, it's a 3-well pad. You see this information, you see average rate, average pressure, max pressure. But what I have the capability of showing, and I have right here, is based on the chemicals that are pumped, I could select those, and below me, it's going to actually show me, and it automatically calculates on a stage-by-stage basis what I've pumped per stage. So for instance, 3 different wells, the 4B, 5B, 3B, and I could see from here, based on this heat map, so this heat map, the darker color we have, that means a higher volume pumped or a higher concentration pumped. This application can be done off concentration or volume. So I could quickly see stage by stage, well by well, which stages am I pumping a lot more FR on versus others, more acid on? Am I, pumping the job to design? Maybe I had to pump a lot more slick water volume on this stage for the 4B versus these other two. Why was that? So the beauty of this too is, again, with a lot of what we have in Corva, and kind of touches on one of the challenges that we presented at the beginning, is so much of completions data that's coming in, and this is best for operational performance, is there's so much going, whether it's a CSV files or PJRs. A lot of times, when you have 150 stage plus pads, and really, engineers, everyone that's trying to optimize, they're just trying to get the job pumped away and keep it as safely as possible. But a lot of times it's very hard to sift through all that data, QA/QC it, and then make it actionable to where, hey, I'm detecting a trend really quickly. Maybe I can catch something early enough to see what the problem is. So for instance, in this particular app, 2 different things. So, and this is actually from a customer use point, customer case, where they were seeing trends with their FR usage over the course of a pad. So they actually noticed and saw where, it kind of changed, maybe about 5 to 10 stages, the higher FR usage versus lower FR usage, and it would flip flop every other day, and they noticed that trend about until midway through the pad. And the customer was wondering, hey, what's going on with this? Why is, that seems odd. Like, let's investigate. And they use this application to actually see, okay, was there an adequate pressure rate response, when we actually pumped that additional FR? Was it needed? Because again, the more FR you pump, the more, basically costs you incur just to get the job pumped away. So they were noticing that. They were looking at the trends for the pressure and rate with the higher FR usage versus lower. They actually didn't see a big increase. So further investigation actually showed, when they spoke with the field, that it turned out one consultant liked running their FR at a higher set point, very small amount higher, but slightly higher set point than the other consultant. So they were actually able to detect that early enough to say, hey, why don't we change this process, look at this to see, and let's bump it down, and then let's see how it goes from there. They noticed pressure rate response didn't have as much of a change. They still safely pumped all their jobs away. But from there, and from that standpoint, they saved a pretty decent amount of cost from just not pumping that additional FR. We've had similar use cases where they're seeing it on acid. Do we need to pump this acid or not? Or, from those trends and those purposes. So capturing that, seeing that, and again, because there's so much data coming in, it's hard to make it actionable and see it. With this, it's very quick and clear because it's automatically calculating, hey, stage 3 in the 5B, I had a lot more FR pump versus these other 2 wells. So, why was that? And then in some cases, you may notice, hey, we had a really low rate and high pressure was popping up quite a bit. So other things had to happen from that standpoint. So just various pieces, and they've used it in both ways, but it's really helped customers, again, organize, aggregate all this data to where it's very actionable, very usable from all those standpoints. Next application, so similar, but really takes it a step further from just optimizing your chemical set points, showing that TVD versus MD. So this is, again, shows kind of the full comprehensive nature of the platform and how we fully drilling to completions and how we close that loop. So what this application does is it actually pulls in drilling data from the drilling phase and then ties it to your completions either on a design basis or on a post-stage well basis. So for instance, let me start on a design basis. So as we can see up here, it's pulling in my TVD over the lateral length, my gamma, MSE, showing you my dogleg severity, but I have the ability to show other drilling parameters. I also have the ability to add other LAS files. So if I ran special, seismic data or lithological data or pieces that are going to tell me how to place my perfs, fracs, so on and so forth, I could load that here as well. So it correlates that and then breaks it out on a stage by stage basis, as you can see here, with the actual design of the stage. So the amount of acid to pump, amount of proppant, slick water volume, so on and so forth. So how customers have used this, and even from my previous experience, it would have been invaluable because a lot of times the way operations work, especially in the field, drilling, sometimes, frac may be waiting on drilling to get off location, and for handover purposes, completion engineer may not have everything readily available from that drilling phase just because operations have to move quickly. They have to do things, very fast nature. So they have to get designs out, have to get moving. So what the customer has done is they actually leverage this application to where on their planning phase, setting up their pump schedules, everything from an operational standpoint, they would look through and they noticed, let's say stages 30 through 33, drilling actually was out of zone. And in the place where they were out of zone, it was actually out in the Permian, and it went from basically a Wolfcamp A well to a Wolfcamp B. They dipped into the Wolfcamp B formation. And in where they were at in Texas, Delaware, it was just notoriously much more tough to treat. It was more of an appraisal well area. And from previous wells that they had in that area, it required a totally different pump schedule. Actually required gel, crosslinker, different set points, the whole 9 yards. Because they caught that, when they got to these stages, they actually saw it and knew it, because throughout the job, they were having trouble even still pumping the job away. So they caught it, they changed their pump schedule, and even though, it still was a little tight to pump it, they did not screen out the well. They were able to move quickly, and it helped them a lot from that standpoint. From my experience, it was kind of the opposite, and unfortunately, I didn't have a tool like this to help me, where similar situation happened. I was out actually in the Permian in New Mexico, fracking a well, and same deal. We learned after the fact that drilling had gone out of zone, and we ended up screening out that stage because, again, we didn't have that information readily available. The gamma, the MSE, everything to tell me, hey, you're out of zone. We might want to switch this up to make sure we get this pumped away more efficiently. So that's on a design basis. And now maybe on a actual post-stage analysis basis, we have the feature as well. So your same drilling data, you could still upload your LAS files from there, but now it's pulling on all your pressure rate data stage by stage basis, but it also has your consumables pumped. So like we had in the previous application where it showed me a heat map of, hey, I pump more FR on this stage versus this stage, more slick water volume this stage versus this stage. We have it all here right here as well. So, let's say we have a case where we're noticing a few stages, hey, these three, man, we had a lot more FR pumped on those stages. And why was that? So outside of the previous app where it's just showing you pressure rate, I can actually correlate to drilling. So maybe I'm seeing, I'm not out of zone, but MSE gamma, my lithology actually indicates, hey, I'm seeing a lot more, this is a lot tighter. Like maybe I need to change, my set points and tweak that to where, again, I can get this job pumped away safely. I don't screen out. I keep operations moving effectively. So that is how customers have actually leveraged this and used this, both design and even, this could be used during the operations as well. Outside post stage, they could actually see what's going on even after they pump. So if they have stages more close to the heel, they can alter what they're doing, be more efficient, safe, and effective from there. Few other applications. So those are two big heavy hitters in terms of how we can optimize our chemical set points, how we can optimize what we're seeing, what we're doing to make sure jobs are pumped away effectively and safely. But a few of these other applications, they just kind of show, again, the full breadth of how we can monitor, how we can improve operationally. So this one's called stage design versus actual. So I mentioned we're pulling in all of the the real-time streams of data from location. What we also do pull in are completions design. So we have design parameters, values. We also pull in post-job reports from the frac vendor, so what they're reporting. So what this application is doing and showing is it's comparing basically what was pumped versus what was actually reported or calculated. So what we do here is, let's say I'm looking at chemicals, proppants, and fluids that are pumped stage by stage basis. And I could basically pick this on a straps mode or calculated mode. So if I want it based on what Corva calculates or based on what's reported via the frac vendor, we could show that and showcase that. So here you see basically it's a bar chart showing the variance compared to where we are to design. So like I said, we capture the design values, so now we can compare those to what was actually pumped. So if I want to see, for instance, if we had to shut down near the end of a stage, in this case, maybe they had to shut down in the middle of the stage due to an iron leak, and we only pumped 55% of the proppant away, it would actually automatically calculate that over the course of the stage and tell you what you had actually pumped versus design, and then that difference. So if you're under or way outside of kind of a 10% threshold, it's going to be in the red. It's going to say 55%. Now, if we have pumped, all proppant, all slick water volume, you'll see this 100.3%. Now, this has come into a lot of use for a lot of customers because it kind of gives them a way. It's their own internal QA/QC method to spot check maybe the way they look at vendors and how ticketing works. So for instance, it'll show you all your design values, and then what you'll see at the end of the stage is the straps, what are reported there, as well as your calculations. So we've had cases where, and again, I could look at the job as a whole, individual stages, however I'd like to see it and visualize it. So from here, we'll have cases where, a job as a whole, Corva will calculate a certain volume of proppant pumped, certain slick water volumes pumped, so on and so forth. And the vendor may have either something way different or in some cases similar. So we've had customers come to us and say, hey, I actually use this quite frequently for my ticketing purposes because it's my spot check to see, hey, did these add up? Okay, they do add up. They're pretty close. I feel comfortable about this. I'll sign this ticket. Conversely, we've had times where they were off and they would go back to the frac vendor and say, hey, I don't think these were right. Can you please check? And they would come back and say, yep, you're right. We're so sorry. So again, it's just another spot check, a QA/QC method of where not just real-time data, but we're pulling in what we call more static data. So showing that information, visualizing it from there. A couple of these other applications, these are just show kind of, again, the breadth of different things Corva can show and visualize. So if, pretty common, trend as of today, especially with trying to minimize, go carbon neutral, lower carbon footprint, calculating and showing our ESG values. So calculating, a lot of fleets are biofuel fleets. So how efficient are they? What are those natural gas substitution percentages? How much diesel am I burning per stage? Because again, that's a big factor on your cost, the overall operations of the job. We can capture that and visualize that from there. So here, this is just showing an example of how we show that information. Let's say for ticketing purposes, calculating average horsepower per stage, crucial to how most frac contracts are structured in terms of, are we hitting those marks? Are they going to hit the KPIs or the pumping hours necessary to receive a bonus? This could capture that, show that, so we can know we're on track or not. Now they're getting to max rate. So this is basically calculating how fast are we taking to get to our optimal rate. This dictates how fast we pump our stages, how efficient we are, so on and so forth. Corva can calculate all of this. But what makes these apps unique is they're actually apps that were built using a SQL visualizer query. So I actually helped create these from our side and have given them to clients, but especially if clients are savvy in SQL, it's a kind of a create your own app that the client can use. So anything, and virtually Corva is pulling almost everything from location, like I said. Anything coming through the frac van, the wireline logger, so on and so forth, we can pull it in and ingest it. So if there's certain, applications or visualizations that we don't currently show, apps could actually be coded quickly and, calculations can be quickly made to visualize this information and show it and calculate it. So just again, shows the flexibility, agility of the platform again to help provide information, make the team more well-informed, operationally efficient, savvy from that nature. Pad metrics, briefly touched on this, but it's automatically calculating your key pumping KPIs per day. So stages per day, volume of fluid per day, proppant per day, pumping hours per day. So here as well, it's going to show you all your wells, all your metrics. we can track and range any portion of time. If I want to see how the frac fleet performed over the last year, quarter, month, 5 to 10 days, I could show and visualize that. So this is a great tool. Again, it's for measuring. You can't measure, you can't improve. So if you're knowing, and you can see, especially for managerial type reports, again, it automates that entire process to where historical users are querying from a database like WellView or OpenWells to pull this information. Yeah, and this is automatically calculating, updating it. It's for a certain frac fleet's performance over time, it's very quick and easy to show that. If I want to highlight pumping hours versus stages per day, again, I just click this. It's going to recalculate all my information from here. So again, great for reporting, measuring, all of that. It eliminates that process, saves tons of time for engineers. Time analysis. So again, based off our activity section, this just takes really measuring your pumping KPIs a step further. So this is actually capturing all of your phase time on a particular pad. So if I want to see when an individual stage on a well is fracked, so this is stage 30 to 3B, it took me 88 minutes to frack that stage. It took me 73 minutes to the wireline run stage 32 for the 5B. It calculates all my swap over times, all my transition time. So, transitioning to frac, transitioning to wireline. Calculates anytime I'm not pumping on the pad. So really, again, showing all my efficiency or inefficiency. So where I can measure that information, know where to target if I'm noticing a lot of surface equipment leaks, failures, pulls in my NPT information. So have the ability, so we corroborate with mooring operational reports and can overlay when we have NPT. So because you may have non-pumping time, but it may not necessarily be NPT. It could have been planned maintenance, greasing a valve, so on and so forth. Going to capture your swap over times, any given duration. So here I have a custom range. Again, I could pick the entire pad, last 24 hours. Finally, this waiting on offset wells time. So this has come into play a lot for our customer base, where they always want to see, especially on these larger pads, a lot of simultaneous operations happening at once. Are they on or off critical path? So meaning, am I getting to a point where I'm constantly having an effective operation? So if I have a 2-well pad, I should always be making a wireline run while I'm fracking. I'm not waiting on anything. I'm not done with the frac stage and I'm still waiting on wireline to get out of the hole. Ideally, everything should be seamless. So this is going to automatically capture that information. So if, for instance, of course, as you go from the toe to the heel, those stages should happen more quickly. You should speed up as you go. You may end up be waiting on your wireline as you get closer to the hill. So maybe, we can change wireline processes, especially as we get up, toe to heel, to make sure those are quickly more efficient. So again, we're not having all this time on or off critical path. So again, this captures that information, visualizes it, graphical and tabular format. So again, measures all this information, makes it very quick and easy to pull together, visualize, put on a report, again, target places for improvement. Your activity detection. So this is just a breakout of what I showed previously on either the frac and wireline phases. So what I can show here, again, as I showed, with that breakdown of those blocks in the treatment plot, how much am I spending or how much time, fracking, wireline, going to flush. So again, it shows me if I'm on path or off path. So again, it's great for reporting purposes. And it's also great to show, I could detail flat time here. So if I want to have an instance where, I want to see how many times, a particular pad I'm having, unplanned shutdowns mid-stage, it's going to capture that. See the gray right here is when your pumps are off. So again, very useful for targeting that. So again, if I'm noticing inefficiencies with some surface equipment, some pumps going out, blowing out fluid ends, I can have my conversations with my customers, say, hey, we need to work on this to be more efficient. And that's what a lot of customers are using this for. And again, it just makes this whole process seamless of pulling all this data together and visualizing it. This shows the frac side. If you click this, the toggle, it just shows you the wireline side. So same type of information from that wireline traces app. Just going to break out when you're running a hole, pulling out a hole, both the vertical and lateral sections. So you can see all this information. Another thing that customers are using these applications for, WellView integration. So for reporting purposes, and this takes a lot of time off of the consultants in the field or even engineers that they're having to fill this out. We're automatically pulling in for these apps, your start time, your end time stamps, average rate, max rate, your total pump time, total wireline run times, average speed, max speeds. All of this, we actually, via our API, and there's a plugin in WellView and other reporting softwares where they can pull from Corva and it's going to automatically plot those pieces. So again, it automates that entire process. And this is really what these two apps come into play a lot for, is takes all that burden off those field consultants again, so they can remotely treat. So saves time. You're not having to have as many consultants or many people on location, saving you money, being more safe from that standpoint. Your wireline time, just tracking all your wireline runs. So if we're, basically on track, if we're expecting all of our runs to be under 90 minutes, it is. Quickly can spot, hey, are we seeing any misruns taking place? Why are those misruns taking place? It's going to show you that information. This is just another application specifying out swap over time. So again, showed how they were calculated on time analysis, but any frac swap over or wireline swap over. So this is showing both frac and wireline swap overs over the last 24-hour period. We can pick any range of time, look at all stages, look at just one well, look at, one, like I said, one well versus the other. I can look at all 3 wells. So it's very quick and easy to look at that information. So if I want to see 24 hours, all, I believe I put all here, it should show me every single stage. Here we go. All the swap overs from this standpoint. So any outliers, again, it's going to break out day crews versus night crews. So if I'm noticing, one particular crew is having, better operational performance on their swap overs versus night, I could see that. Of course, over a range of time, it's going to actually give me my averages. So if I want, to see, hey, all my wireline swap overs look like they're about 20 minutes, frac about 28 minutes. Again, graphical, if I click this button, I have a tabular format. So I can see individual swap overs, all the numbers, noticing any trends, all of those. Obviously, it calculates your day average, your night average. And then up here, you can see, overall average. One other thing I wanted to highlight and show as well, so if I go back to, let's say, the 3B, and I pick maybe last 24 hours. Let me go to, there we go. So you can see, individual swaps. Obviously, if you highlight over, it'll show you the amount of time. But if you can notice, there's a goal set. And so a lot of these applications have goals that you can note and set, whether they're swap overs, whether they're for stages per day, those KPIs. So these are great for reporting. Putting these on a report, showing it to the field, obviously shows operational performance, but also it could be used as a motivational tool for the folks in the field. They could see the information, make them aware, highlight process, focus and work from there. But we have the ability to change those goal settings. So maybe I don't want the goal to be at 15 minutes, I want it at 30 minutes. I could set that from here. And then if you're above or below your goal, then you can see you're in the green or you're in the red. So quickly showcases, pulls in that information from that standpoint. As well, NPT information. So like I said, we're pulling in the NPT information from those reports. So basically our system has 2 different ways of pulling in more static based information. We parse it out through what are called parse bots. So those actually automatically pull that in and put it to our system. Our analysts then QA/QC that information, as well as check, look, and verify that they're going to the right spot. So it can detail, single well NPT, within a click of a button. You can look at overall pad NPT, well NPT. If I highlight, one well versus the pad, graphical tabular, it's going to actually break out what the NPT was on, whether it's screening out of the well, waiting on proppant, the amount of time, day versus night. You can see all that information and view that from there. So wide variety of kind of all the different applications we have from this side. So very, very useful. A couple other quick items I wanted to cover on just while we're in the platform relates to our feed feature. So our feed feature also covers basically all the information that's loaded into the platform. It's kind of like a combination of Microsoft Teams, but with all the usage and functionality of Corva. So again, we could automatically create, stage reports that could be sent to teams. So again, shows that integration, pulls in all this information. So again, all that communication that's typically being covered, it's pulled out of there and it automates that process. But this is great for, our applications, and I'll even show it on one of them here, like our treatment plot. We can actually annotate this plot. So let's say if we want to communicate cross teams, I'll go back to the active stage. I'll take off these offset wells. But if I want to annotate this plot, this bottom piece right here, I can actually click on this and I can annotate a particular plot. So let's say if I did have a mid-stage shutdown, I could click on this and then I could say unplanned. And this could be anything. It could be a plug slipped. It could be any use and functionality. But the beauty of this is I could make this note and then it'll be locked into this app so that other users could see it. If let's say maybe I'm a consultant out in the field and I want to share this with my superintendent in the office, or somebody else, I could do that here as well. And I could actually tag another user. So now I could pick this user, click that, click this right here. And now this note is made here. So now it'll always show, and that user is communicated so that they were tagged in that. They could actually see what's going on. They could click on it. They could also use our feed feature to search for it. Again, find information in terms of if there's reports uploaded, all of that. It's all one spot for all this information, as well as people can communicate amongst one another with this feature. So very useful and very, it facilitates all that communication, makes it very, very actionable from that standpoint. So that's our demonstration of the platform itself. Go back to the slide deck. So just a couple other quick slides that we have. So this is actually data that was from a trial we had about last year with a operator in the Permian. They're now a commercial customer, but some of those applications that I showed. So they really wanted to focus on some of their operational pieces. So their swap over times, their basically how fast they can get the max rate or get the rate. Certain practices to use for that. Wireline run savings, so minimizing those misfires. So using Corva and seeing this, they were actually able to kind of quantify the savings. So again, this is over the 3-well course of a pad compared with one pad to the next using Corva. And overall, they saved about a day between pads, just leveraging this information, making their field crews aware of kind of what was going on and changing just processes. Again, a lot of this, you can't measure, you can't improve. And if you utilize this information correctly, could really help. So, they saved between pads about, $56,000. And the way they look between this, overall savings, if they continue this, let's just say assuming 40 wells, obviously last year, operations weren't as heavy as they've been in the past, but could be close to 33 days of savings. So significant amount, almost $2 million, which then, that's another well you could frack at the end of the day, lead to more production, so on and so forth. So really, having all this information available, having it actionable it just makes life so much easier, and it just allows for so many operational efficiencies to come from that standpoint. One other piece I wanted to show, and this I touched on at the beginning as part of our enterprise piece of our solutions that we provide, but again, all this information that's coming in, we're pulling in your design information, the actual volumes pumped, all the rate, pressure, everything virtually coming through the field. It's QA/QC analyzed, but what we can do from that standpoint, like I said, utilizing, Corva has what's called an open-ended REST API to where information can be pulled from Corva to populate a variety of other internal tools. So again, enables that integration between tools such as SPOTFIRE, Power BI, Microsoft Teams, WellView, so on and so forth, all these features to where, like I said, Corva, we aggregate all the data, clean it. Again, we have our own visualizations and tools to make it actionable, but again, this is the one place, because again, if you're trying to pull SPOTFIRE tools, it's from previous experience of trying to pull this data, it's very tough to wrangle it all together to make it so I could load it and make it actionable. You probably have to download multiple CSV files. It gets very, very tedious. With Corva, it's you just make a quick call via the API and it can automatically populate your SPOTFIRE dashboards. And even from there, and from that standpoint, it could be, you don't have to re-upload a file. It could be a continuous pull of the API, pull from Corva's API to populate these dashboards and use it from that standpoint. So that wraps up my presentation. I really appreciate everybody sitting in and listening, and I'm happy to answer some questions now.
Thank you again, Michael, for your time to share this, your platform and your tools, and talk about some of the science behind it. Looks like we have a question that's been submitted. That's let me repeat. So have they tried going back and doing analysis on the data they are pulling, like wireline run, stages pumped, etc., to be able to build a predictive model specific to their customers? Do you know if that functionality is there?
So
sorry, go ahead.
Real quick, can you repeat that question? Just building, is it detailing more? I can probably pull up the questions as well.
Yeah, let me, okay, they clicked into the pin yet. It says, have they tried going back and doing analysis on the data they are pulling from like this frac fan and all that to be able to build a predictive model specific to their customers? See if I can unmute her.
Oh, no, that's a great question. So that is actually something that has been brought up. So that's something more, especially kind of on the predictive measure that we're looking to build. So it's a case by case basis too, in terms of how that would go about. So one of which is it's kind of using our alerts feature. So we've been asked to develop some alerts to fire and note when plugs are setting off depth, and when that happens, what setting is it off depth. So the whole kind of at the end of the day, and this is kind of a Corva wide, is integrating full integration. So it's with partner companies. It's whether it's working with certain frac vendors, wireline vendors, to where we have all the, again, it's the repository of information, everything kind of coming in to where we'll have kind of the optimal set points, the optimal parameters, the optimal running speeds, to where we could feed into, and this is actually taking place on the drilling side right now. Essentially, we have like a driller's roadmap that, because we have kind of a database of the proper parameters, set points, all that to use, that we feed into, a company to where it works into the rig's infrastructure to where it automatically will drill. So we're looking to build that more on the completion side in due course as we partner and use other vendors and companies, because of course they control the equipment, we're just the data guys. So that is definitely something on the horizon, but we're already starting that process on the drilling side.
All right, awesome. Hopefully that answered the question. And then I guess I was just curious, you mentioned frac hits app, like what sort of analytics behind there? Like, is it just like if there's detect like a spike in pressures recorded, like how do y'all approach that? Is it like a predictive? I know you're like working predictive for this other thing, but do you have like predictive analytics say, hey, there's something going on, there's like a spike in production or something like that? What sort of logic do you have on there? Just curious, because I mean I've seen a lot of folks talk about that nowadays, is like frac hit detection and protection and all that.
Yes. So it's definitely, and it's a complicated question, really, because there are a lot of factors in play, and eventually, and we've been asked this, we have a couple of customers that are actually working with us for kind of custom development, kind of using their intellectual property through another feature we have called the Development Center, Dev Center in Corva, which is basically kind of a customer portal where they can leverage our infrastructure, but their intellectual property to build off of it. So as of right now, we're more focused on kind of just a general threshold. So typically we'll discuss with the customer, and if we're seeing a pressure on these offset wells, and again, it is hard to tell. Probably a pressure where obviously if you hit a certain amount, you've hit the well, the damage has been done, so to speak. So kind of a preset, instead of maybe 3,000 PSI, you're at like 800 or 1,200, so to speak. So an early threshold to be, hey, stop what you're doing, shut everything in, just look, take it, well, not shut everything in, but stop the frac, stop, drilling if, drilling rigs close by that producing well, and let's just monitor and see what's going on. So we have customers using that from that standpoint. Now, more of a predictive basis, we are in discussions of how to do that. We're kind of working on that phase. I will say more predictive wise, especially for, it's more of the real-time pumping aspect. It's kind of again, leveraging, historical wells. So let's say it's kind of an FR optimizer to where we leverage historical wells, basically their treating data, and you base it off of, an area, a target formation, certain rate threshold, so on and so forth, to basically tell you, hey, can I get away based on my offset wells? Can I get away with, bumping my FR up or down, or however, to make sure I, maintain a certain treating pressure. So that is something more we're currently looking at and working on, in terms of kind of predictive analytics for frac hits. That's still up, and that's something more too where we want to leverage, utilizing production rates from a company, so on and so forth, so we can kind of close the loop. But really, right now, it's kind of just looking at, and it kind of as an industry, it's tough to integrate it totally. And that was a big win for us, in terms of just getting it in and then correlating that alert or that kind of threshold to say, hey, something's up, let's stop what we're doing, monitor, and then go from there.
Okay, awesome. All right, so we got some more questions coming in. I don't know if you can see the panel there, or okay, here's this one has quite a few questions, parts to it. I guess related to the wireline data collection itself. Have you guys seen any uptime issues with your data collectors? connected to wire line and pump down. Example, like serial cable accidentally unplugged, truck's turned off, power supply cut, collector turned off. Oh, I guess it's a long question, but this is just around if you had issues, the uptime issues with data collection for the wire line.
Sure, sure, and it's a very fair question because that does happen, and it's not even it's not always exclusively wireline. Well, you'll see it in frac too sometimes, where something may happen, power surge, but you will see it more often in wireline. So from our end, we don't see it, and the reason why is because luckily with our box in the van, and it's kind of the whole concept of can we, if something happens, if a channel mapping is swapped, if we're seeing some issues. Is the box still able to collect the data? So no matter what, as long as we're connected and we're seeing that and have that from there, and if it's streaming in the logger and obviously they're able to operate and go from that standpoint, we'll be collecting that data. So even if transmission from our side to the cloud is off for a second, it'll actually be held in the box and it'll still keep storing that data. Now, internet connection comes back, it starts repopulating and it'll repopulate in a matter of seconds. Now, we've worked with a variety of vendors to make sure, based on the area we're in, that we don't have issues with, transmission, or we have the right internet or comms basically in place to make sure we don't see that. So that's been definitely a process we've honed on over time. But in terms of collecting, making sure we have it and eventually transmit and lag, we don't see it.
Okay, awesome. I guess there's another part. Are you able to receive voltage data from charges that utilize an external shooting panel to Warrior?
Very good question. So that is actually something new that we are integrating into our platform. So yeah, exactly. We can get those pieces in there to show exact, and that's going to actually correlate to a lot of newer things we have related to actual fire, perforation depth, shot, having all that, because that can then correlate to one, you see that information, but you could also automatically upload it into, like if we're putting it into WellView. So for loading all of that, so again, a consultant doesn't have to automatically or manually type in all of that data. So that's something we're working on right now. Same with pump down. So pump down, feeding through basically to make sure it's all correlated in from that standpoint. So we have it all kind of set separate, like we'll have a box connected to the pump down. But again, when it's streamed through Warrior and they have it kind of all connected, it'll all come in the same spot. But we're working on the shooting panel right now to get that in.
Okay, awesome. And then the next one we got is what sort of ETL process do you employ since you're pulling data in from various sources, and what unique challenges have they faced with that?
So I would have to kind of double check on some of the pieces ETL wise, but really in terms of it's way it works, it's basically serial data out. So whether, if we do have, something like Warrior, we do and will provide, like what's called a Moxa box or a PLC, that programmable logic controller, to make sure we get export that and get that out. So really, if we have that, and typically there's always some type of data acquisition system from that standpoint, it could go in, it'll go to our box, it'll configure it to so where, and that's the beauty too of kind of how we work as well, is we have a team of field representatives that are former E-techs that work with a variety, many frac vendors, wireline vendors, to where they, the process of the install is very quick. And one thing I'll say too is with what we do and how we install, it's very minimal footprint on what we have to install. So there's not a skid, there's not, somebody required there at all times. It's literally a 30-minute upfront type of installation. Typically, like I said, it's a serial port out and basically plugging in from that standpoint. But in terms of, kind of the smaller pieces of it, I'd love to, we could follow up and kind of communicate all those processes though.
Okay, great. Appreciate that. So the next one I got is, are you able to account for slippage whenever there are greasing issues with wireline and help with the greasing plan set out by operators?
It's a very good question. And I will be honest, it has not come up too much, but it's definitely something that that we do want to incorporate in the future from that standpoint. So, and again, And then that's even going from that piece to, when we're monitoring, and this kind of goes, broader scope as well, but, monitoring anything else on location. So not just slippage of the reel, but we're talking, how often are we greasing our valves to make sure, basically we're doing it accordingly so we don't have any iron leak issues. Ideally, we want to, and we're working on ways to connect other pieces of location. So water transfer rates. We want to see, proppant delivery, silos, like the full logistics piece. Because again, because where we're set right now, it's more based on we're plugged into the frac fan. So if it's coming through the frac fan, we could show it. Coming through the logger, we could show it. But a lot of the external pieces on location, we're working on ways to have that, to show that information, because that's a whole other part of the picture that's really important in terms of, like I said, operational performance, how we're going to make sure, basically upping that efficiency that we have on location.
All right, fantastic. Is your next one, is your activity detection logic based off of incoming data, or is activity type a user input?
Very good question. So by and large, I would say 90% is off of logic, so actual coded logic that we have. And that's for frac or for wireline. Now, some aspects of the frac side, there's always going to probably be something where coding may not have every edge case possible. So that's where we have some editable features to where, we can have, and just like you'd have in the frac van for the frac engineer, they would pick breakdown, they'd pick ISIP, certain aspects that may go outside the realm of the activity section. Now, I will say the activity section is very good at covering it all, but that's the beauty of our operations center here in Houston, where they all have industry experience, and then they could capture and they could actually manually override that piece and tweak it from that standpoint.
Okay, great. And then there's another couple of two other questions with that. One is, how do you make yourself data agnostic?
Yes. So the biggest piece of it, and that's more related to how we can relate, how we can tie into the various vendors. So like I said, certain pieces of the actual data transmission and acquisition. Like I said, if you want to look at certain vendors like a Schlumberger or Halliburton, well, I guess they're Liberty now, but some are run off of what are called Lime, or some are run off called MDT, to where basic pieces, and the basic piece of our box is, again, we don't install any sensors or anything out on location. The only thing that goes on location is it's literally a box, probably the size of an internet modem, and it's typically plugging into the serial port in the van. So, and I'll say from our end as well, kind of the whole process of how it works. Really what it does is if it's any type of serial data, which virtually, any frac fan's gonna most likely have that, and we haven't run into anybody or any issues. And pretty much anything, even lower 48, actually Canada, they don't run off Warrior, a lot of their wireline loggers, but if it's off Warrior, that type of data, we can ingest it. And then basically from that standpoint, if we have to use a PLC or a Moxa box, any of those pieces, we can convert it however necessary. That's, again, our deal of taking the burden off the customer, all those pieces as well, to make sure, again, pulling that off location, and then, whether it's, Liberty or Halliburton or Schlumberger or whoever, pulling that out and being able to do it. So really it's kind of, as long as there's a base level of data, we've been pretty successful in the past.
Awesome. And then what is the turnaround time on a new type of data being integrated in the system and displayed reliably?
It depends. So I will say the latest piece that we've been working on, it's basically pulling through an API. So integrating other methods, trying to look and see, like I said, if it's water transfer, if it's proppant silos, if we're trying to integrate production data, probably via the API would be our best bet. But for instance, a good example. So a few months ago, pump down was not a piece that we were able to pull in. But the ability, since there was a data acquisition system that we could basically tap into, I'd say once we actually looked at it, within a month, we were able to actually stream it and have it visualized. Same with the offset well pressures, ability of that. And again, the fact that it was, kind of worked into being able to be streamed into the frac van, going from there, I mean, it was a pretty seamless transition. So that didn't really take any major development or time at all. But I will say, depending on what the ask is and what we're trying to do, the aspect of it could take some time, but it's more of a case-by-case basis, but we have been successful in the past.
Okay, awesome. And then to that one, does your install equipment have to be installed between pads such as antennas or data acquisition boxes?
Very good question. And it does not. The only time, and it's kind of, we've run into some issues, and kind of goes without saying, but obviously when we swap loggers, I mean, it happens fairly frequently. The box will need to be taken out of the logger, but it's a very quick and seamless method of literally it's a serial connection. You unplug it and plug it back in. It'd just be like a TV. So, but if moving pad to pad, well to well, and you're not swapping anything out, you just literally stay there. The channel list has already been set up front, so it's plug and play from that standpoint. So it does not need to be changed out or removed.
Yeah, awesome. Well, I think that all answers I had were questions I had were answered, and some good ones submitted by the folks. And if I somehow missed your question, feel free. I can send you everyone's email or Michael's email to everyone, or you'll get Corva will get your emails, so they can reach out to you if any questions, or you can just post in our LinkedIn page. Yeah, no, I appreciate everyone's time and your attention today, and also your time, Michael, to talk about Corva and some stuff you're working on. Yeah, but any other questions, I guess we can cut it short and give you guys some time back. Yeah, again, I really appreciate your time, everyone, and here's Michael.
Yeah, no, I appreciate it, everybody, and Anthony and the whole SPE data analytics group in the Permian. Like I said, they'll provide my email, and we'll be reaching out to you separately as well. So we really, really appreciate everybody's time today.
Thanks, guys. Have a good one.
Thanks.